Hello, how's it going? I am Matias a Gaseota Gracia. In this video, I'm going to teach you how to design from three-dimensional models and visual programming with Rhinoceros and Grasshopper. We are going to make a building, designed by me, arise from series of prototypes from architecture and modern design. The first step will be to do an ellipsoid. For this, we should use the components on the panel. This tool. The dimensions will be 9 meters of length and a width of 5 meters. I'm referring to the ellipse. Then a height of 28 meters and 30 centimeters. This tool works with radius, so we will use 4 meters and 50 centimeters approximately and 2 meters and 50 centimeters. Once the dimensions have been established, go to the front screen after clicking to establish the height. Click, and then we have the ellipsoid done. Well, open Grasshopper. Grasshopper command. And look for the perspective screen. Then go to the Grasshopper panel. To begin programming the building's floors. Well, click on Parameters and deploy rep. We will introduce the ellipsoid in this component. Set one rep. So we should select it in Rhinoceros. Look, our element has been selected and introduced. Firstly, we will determine the volume, which will establish the center point of our geometric figure. So click on Surface, Analysis, and Volume. Then match Rep with Volume. Now click on perspective to put another view, wireframe. So we have our center point. From this point, we will determine a number sequence to establish planes. So, click on Sets, then Sequence, and Series. At first, we will form the component, and then it will be connected to other similar components. Well, from the component volume, we have to join a geometry that gives us the volume and the centroid of this geometry. This series of numbers permit us to move the centroid upwards many times. To do this, the component that will be assembled asks for the first number of the series, the distance between each element, and the quantity of elements. Go to Params, Numbers Later, double-click to edit. And then integer numbers, a maximum range of 30. Copy this, Ctrl+C, Ctrl+V, now we should connect these three elements in order. We will start from 0. The distance between each element will be 1. Remember that the elements of the series will be the center point. So we should put 27 or 28 elements. Once we established the series, we will determine the movements. Well, to do this, we click on Transformations, and then Move. The geometry we have to move is the centroid. Now we can connect centroid with geometry. We need another element, the vector of direction of movement, that is our z vector. We have a predetermined movement for the component. To make the movement on z vector 27 times, we use a tool called amplitude. double click in the panel. This tool permits us to combine the vector of direction in which we will move and the series that has been conformed to connect it as a vector in the movement. Click on vector, then Z vector, so we combine the motion vector and the series of 27 elements that can be moved. I will show you the modifications we can do, starting from different values. For example, if I start from 3, I will rise. In this case, we start from the beginning, the centroid 0. Now, look, the distance between the element of the series, I will move away so you can see it properly, 2, 3, 4. We will keep it in 1. And now the quantity of elements. That can be the quantity we want. I will keep it on 29. One more. So, we will establish the planes for each floor in every point of the series that started from the centroid of volume. Click on primitive. And then plane surface. Once we have our component placed, we connect each centroid in the component. There will be one plane in each centroid element. I mean, the series of points from the centroid. Now we have finished the first part of the tutorial. Regards.